today. So in data warehousing, um, there are few concepts that are very important for the ETL. Okay, number one is uh, slowly changing dimensions. Okay, slowly changing dimensions, uh, and then what what are dimension tables? What are fact tables? Okay, primary key, foreign key, um, also system generated key. Okay, this has a the system generated key also has a different name. I'll tell you what it is. Um, okay, what else? Okay, let's see if we can cover this today. Okay. Uh, okay. So in ETL we have different tables, right? I mean, in data warehousing we have so many different tables in the data warehousing area. So in those different tables, we have two types of tables. Okay, they are mainly there are two types of tables. One is dimension tables. Okay, and other one is fact tables.
Okay.
Okay, so dimension tables and fact tables, and I'll tell you what are the dimension tables and what are the fact tables. Okay, here you can see the diagram, right?
Yeah.
So in this is a table, product is a table, customer is a table, salesperson is a table, order is a table, time is a table. Okay, so in those tables they are connected, how they are integrated with primary key and foreign key. Okay, right?
Yeah.
How the tables are integrated using primary key and foreign key. So that is how you define the relation between the tables. So that in order to join those tables, you need a primary key and foreign key. Okay, so here, let's see. Product table, what are the columns product table has? Product key. So it's a primary key. Okay, product name, product code, product line, RAN. So those are the simple columns in the product table. Let's see this table, customer table. Customer table has a customer key, which might be a primary key, then customer name, customer code, status, address, state, zip code. Okay, right? So this let's just take only those two tables, and then now let's go to this table, order fact. Okay, product key. So where is the product key? Where else also you see the product key?
In the product
In
table.
product table, right? So this is a product key, and in the fact table, so for now just forget about the fact table. Okay, just only remember it's an order table. Okay, so the order table has product key, time key, customer key, salesperson key. So these are all the keys. These are all primary keys for these tables. Okay, for the four of these tables, these are the primary keys. Now, what is the next one? Next field, order dollars, cost dollars, margin dollars, sales units. Okay, so you guys see any difference between product table and order table? So try to find out the difference between the two tables.
The product table doesn't has cost details, whereas order table has cost details.
Okay, good. So yeah, So the product table only has just the product information,
Yeah.
nothing else. Okay. Same thing. Customer table has only the customer information, nothing else. Salesperson table also have same. So these four tables are, they just have their own fields and own data. They don't have any numbers like units, like how many items, how many products. So those kind of information they don't have. They just have just the details. Okay. So if you see this table, they have order dollars, cost dollars, margin, sales units, all those things. All right. So they, what are they? They are like units price, right?
Yeah.
So this is the units. That means number of items, number of products. But what are the other three fields? They are amounts, money, right? So that is the difference. So these are all called dimension tables. Okay, the product, customer, salesperson, time. These are all dimension tables. Okay, and the order table is a fact table because they have fact. Fact means measures. Measures means money, units, number of items. Those are called facts
Fact.
or measures. Okay.
Yeah.
So fact table, it will contain facts. Otherwise, you can also call it measures. Okay. Like price, units. Okay. So those are fact tables. This is a fact table. And this is a dimension table. Dimension table will have dimensions. Dimensions mean information like name, product name, code, address. All these things are called dimensions. Okay. Product information, name, address, etc. Okay. So those are the two things. Okay, you guys understand the difference, right? This is
Yes.
very important, guys. Even in the interview, they will ask you what kind of uh, what are the fact tables you have in your previous project. So you have to give some examples. Like, so I can give you some example tables. They are like sales table. Okay, sales table will have measures. Measures means numbers like what are the sales, units, price, amounts. So, and then another example you can see here is order table. Okay. So these are the examples for fact tables. In the interview, they will ask you the question, what were the fact tables in your previous project? Okay. What were the dimensions? Tell me some dimension table names that you have in your previous project? So you have to name like customer table, salesperson, product, time dimension. So time is also a dimension, even though you can see in numbers, but time is a dimension. Time is not a measure. Okay.
Yes.
Okay, so that is a difference, and then those are the definitions for the dimension table and fact table. Okay, so next, you guys know what is the primary key, right? You guys need any explanation? Are you guys good?
I'm good, sir.
Okay, you,
Yeah, I'm
um, Parmesh. Okay, primary
yeah.
key, foreign key, simple. So I can explain here what is foreign key. So product key is the primary key for that table. Customer key is the primary key for customer table. Why these keys are in the fact table? Can you guys tell me?
I mean, these two tables are connected using the product key.
Yeah,
Those four
yeah,
are foreign keys for this order, this table.
exactly. Yeah, right, right. Good. So these are foreign keys to the other dimension tables. Okay. If you want to join them, you join using the product key here and the product key here. So this is a primary key for the product table, but in the order table, this is a
Foreign.
fact, foreign key to the product table. So those are primary key and foreign key. Okay. So there is another thing called system generated key. Okay. There is another name for the system generated key. I can just remember it right now. Okay. Surrogate key. Okay. The word is it's called surrogate key. Okay. Okay. So let's see what is the surrogate key. I just want to show you a diagram or something so that it will be easy. Okay. Examples of surrogate key. Okay. Okay, so we know what is the primary key. Now let's look at the surrogate key. So surrogate key is a column or set of columns that can be declared as a primary key instead of a real natural key. Okay, sometimes there can be several natural keys that could be declared as the primary key, and these are called candidate keys. Okay, forget about the candidate key. So surrogate key is a candidate. A table could actually have more than one surrogate key, although this would be unusual. The most common type of surrogate key is a incrementing integer, such as auto increment column in MySQL or any sequence in Oracle, any of those tables. Okay. So, as I said, simple. The surrogate key is a system generated key. Okay. I can show you an example in my data warehouse. So why do you need a surrogate key? Okay, that is the question. So why do you need a surrogate key? There are sometimes some tables, how they will be built is only with the dimensions. They will not have any keys sometimes. So let's take where is our diagram? Okay, let's take a time dimension table. Okay, what is a time key? Okay, so the product will have a product key because the product have the product ID and all those things, and the customer has customer ID, so you will have the primary key. But for the time dimension table, how do you create a time key? Okay, so there is no way of creating a time key other than using a system generated key. Okay, the system generated key is nothing but in Oracle it's just a sequence. Do you guys know the sequence in Oracle?
No.
No? Okay. So if you guys have an idea of SQL Server, in SQL Server ID, do you guys know the ID? It's called ID, I think, in SQL Server.
Identity.
No?
It's called identity function.
Yeah, exactly. Identity function. The identity function, it will create a random number, otherwise a sequence number.
Yeah.
So if you give if you give 1001 as the first number, and then increment by 1. Okay, then what will happen is every time the row is inserted into a table, the identity function or sequence in Oracle, it will basically add increment by 1. Okay, 1002 plus 1, 1003 plus 1, like that. So these are called surrogate keys. Okay, so that is how the system will generate. You can give any number here. Okay, if you don't want 1001, you can give any number here. You can put 9999 or 999, and then just give how much you want to increment every time the job runs or every time the row is inserted. You can give that value, so that function will automatically generate the number for you. so that you will have the surrogate key. Okay, so that is called the system generated key.
Okay.
Let me look up something. This is Oracle. Okay, the using a SQL developer. It's a tool for Oracle to connect to Oracle table. Okay. Just trying to find any surrogate keys in my tables. Okay, this you see the sequences. Okay, this is the function or a program that will generate random or sequence numbers for you based on the code you give. I'll show you the code also. So see, increment by 1. Okay, minimum value 1, max value. Okay, you can give the maximum number like this based on the database. Okay, and then these are statistics basically. What is the last number inside the table? 104180 is the last number. Let's see what is the code, how the code looks like for the sequence. Okay, so create sequence and then you'll give the name, minimum value 1, max value 99999, increment by 1, start with 104180. That's because it is already generated sequence number for some table, and then it is stopped at this number 104180. It is stopped. So next time the job runs, it will start with this number. Okay. So that is the sequence, and then that sequence will generate numbers. Can you guys mute your phones? I hear some noise. Okay, good. So this is done. These 3 are done. Let's go to slowly changing dimensions. Okay, now we know what are the dimensions. Now we know what are the facts, right?
Yeah.
Now let's go to slowly changing dimensions. Where is that? Okay. Another couple of things we want to know. Star schema and Snowflake schema. Okay, so I'm just picking up the main and important concepts from the data warehousing. Okay, I'm not going to explain everything in the data warehousing because that will take at least more than 1 month. Okay, so I'm not going to do that, but whatever the important things for the ETL purpose, I'm only explaining those things because data warehousing is a very huge concept. It's not going to finish by 1 or 2 days. So if you can see here, just I took I took one PDF. It has 602 pages, and if you look for Bill Inman or some other data warehousing books, they are very huge. Each book has 1,000 or 5,000 pages. So it's not an easy concept, but we only need these important things. Okay. Okay, let's go to slowly. Okay, we already know dimensions and facts, so that's why let's go to star schema. It will be easy. 232. Okay. So yeah, we can just go through this diagram for a couple of minutes. Okay. So I explained yesterday, right? Source system. Okay. From the source, what we do? What tool we use after the from the source? We use
Extract.
ETL.
Yeah.
Yeah. Yeah. So this layer is a ETL layer. Okay. So we extract the data from the source system. It could be anything. Then you apply the transformations. Then data quality. Data quality is a part of ETL. Okay, that means you're checking the quality of the data. For example, let's let's take an address. Okay, we have an address, street name, right? 100 Main Street. Okay, so the street, sometimes we can write the street like completely street. Otherwise, we can just write st and then put the dot. Okay, so it depends on your organization. You can define the rules for the addresses and then apply those in the when you are doing the data quality. Okay, if your organization wants street complete name street, so you define those rules and then you will just apply those in the transformation. So you will have the at the end of the process, you will only have same type of names for all the addresses. Okay, so that is the data quality. Data quality is nothing but you're making sure the data is um, uh, like constant throughout the data warehouse, and then the quality is good. There is no duplicates, uh, like that. So data quality is making sure that your data is good. Okay, in the at the end of the process or in the data warehouse. Okay, so this is a data warehousing layer. You can see here data warehouse and data marts are in one area. Data marts are nothing but a table. Okay, data marts are nothing but a table, but data warehouse is included a multiple tables. Okay. Okay, then after the data warehousing layer, this is the information layer. Information layer is nothing but reporting. Okay, you can see here dashboards. Dashboards are reporting. In Tableau, you have lot dashboards, queries and reports, so scorecards, online analytical processing, OLAP. Okay, alert system. So everything. Data mining. Data mining is nothing but just going to the data warehouse and then based on your requirement, you are going to mine the data. Mining, going through the history and then bringing back and then creating reports. So that is called data mining. Okay. So yeah, this is a simple diagram for that. Now let's go to star schema. Okay. So star schema, there is another concept in the data warehousing. It's data modeling. Okay, do you guys know what is data modeling?
No.
No.
Okay, okay. So data modeling is also okay. So before I'll give you an example. If you have if you are going to get a new project, okay, in any company, if you are going to start a project, first thing they will do is they will design the tables. Okay, what is the first thing?
Design.
Designing. In any project, designing is the main thing. You have to write your design on a piece of paper. You have to design how do you want to execute your project. Okay, so first thing is design. Okay, next thing is after you design your project, what is the next thing in data warehousing area? Data modeling will come into place. Second step. Okay, data modeling is nothing but, so we were just talking about dimension tables and fact tables, right? So that is the data modeling. You have the keys, you have primary keys, you have foreign keys. Who will decide those? Okay, how do you name those? How many columns you want in a table? How many keys you want in a table? which ones are fact tables, which ones are dimension tables. So all those things you decide, and you create a you create a data model. You create a data model. Okay. I can show you a simple data model. Uh, hmm, okay. Somehow I don't see. Maybe I don't have an access for data modeling. Okay. Tools. Uh, Data mining. So we were discussing, right? Data mining. So you can use this option. Data services, OLAP. Okay. So what is in the OLAP? If you see OLAP, create fact and dimension table, create time dimension table. Right? We were discussing, right?
Yes.
Okay. So, okay. Here is the data modeler. Okay, I'll show you what is the data modeler. Table or type view, data modeler, domain administration. Table or view wizard. Okay, I think, I don't know, it's still not opening. I opened it, but anyway. Okay, that's fine. So data modeling. Okay, data modeling is nothing but deciding your primary keys, foreign keys, dimension tables, and fact tables, how you want to name your columns, how you want to name your tables. Okay, so that is the data modeling part. Maybe we can look at a sample image of a data model, and you will know. Okay, this is a very good example of data model. Okay, so here, see, a sample data model. So you, first of all, you design your tables. That means you put your names and everything on the paper. Then you go to a data modeling tool, um, and then do like this. Okay, you have a person table and you have a company table. You have a person ID, and then it's a primary key. And in the company table, you have a that contact person ID, which is the same thing as a foreign key. So this is the data modeling. Okay, this is how do you connected your tables, how many keys you have. So you can, this is a physical thing. Okay, the data model, once your data model is done, you can upload your data model into your company's SharePoint, so that everyone can view. And then if they need it, for example, in the future, once the project is completed, I wanted to create a query. I want to write a query by joining couple of tables. Okay, for example, let's take this table and the property table. Okay, I want to join these two tables, but I don't know what is the connection, what is the connection between these two tables. So what do you do? How do you know the connection, right? So then you can open a data model like this, data model diagram like this, and then you can find out how can you join these tables. Okay, let's say offering event ID, and then so you see here property ID is here, property ID is here, offering event ID is here, but this doesn't have a property ID, right? This table doesn't have a property ID. So how do you join these two tables? So you have to go to this table and then join these two based on offering ID. Okay, see here, offering ID. You join these two tables, then use the property ID from this table and then join the property table. Understand?
Yes, sir.
Yes.
Okay. So that is the main use of data model. Basically, you can go back to the data modeling diagram and then look how the tables are joined and then look what are the keys. So basically, if you want to join these two tables, you can go to this table and then use the keys basically. Okay, that is how you can use the data model diagrams.
Yes.
So for that data modeling, you just have to know the basic idea how to read the data model. Forget about creating a data model, but at least you have to know how to read the data model for the ETL purpose. Okay. Most of the time there will be a separate data model or modeler in every company. So like same like ETL developer, there will be a data modeler. Okay. Any questions so far? We have two more things to cover in 15 minutes. Any questions?
No, sir.
Okay. So I sent you that link for this PDF to you guys in the WhatsApp. Yeah. Okay. So tomorrow or today, once the class is done, go through and then be ready for tomorrow. Okay.
Yes, sir.
Okay. Now star schema. Okay. What is star schema? I'll show you the diagram so that it will be easy. Looks like this PDF has very good information. If you can read it, it's good. Okay, so this is the diagram for star schema. Okay. What is the product? What type of table is product?
Dimension.
Dimension table. Okay. Order date, customer, salesperson. These are all dimension tables. Yeah, good.
Yes, sir.
Yeah.
Okay. These are all dimension tables, and then if you see the order, it's a order table is a fact table. Okay. So one fact table is connected by 4 dimension tables, right? Okay. So I would like to see a definition. Okay, the star schema. Now that you have been using star schema, let us take a simple example and examine characteristics. I want a definition for star schema. Okay, review the basics of star schema. Let's go to there. Okay, that's fine. I can explain. So for simple star schema, it consists of order and fact table shown in the middle of the schema. Surrounding the fact table area are the 4 dimension tables of customer, let us begin to examine this task. Look at the structure from the point of view of the marketing department. The users in the department will analyze the orders using the dollar amounts, cost, profit margin, quantity. This information is found in the fact table. Okay. The users will analyze these measures by breaking down the numbers in the combinations by customer, salesperson, date, and product. All these dimensions along which the users will analyze are found in the structure. Okay, that's fine. The star schema structure is a structure that can be easily understood by the user and with which they can find comfortable work. The structure mirrors how the users normally view the critical measures along their business dimensions. When you look at the order dollars, the star schema structure intuitively answers the questions of what, when, by whom, and whom to whom. From the star schema, the users can easily visualize the answers to these questions. So anyway, the document is simply saying that you can use this schema to analyze the cost, margin, order, where the product is went to, who is the customer, customer name, who is the salesperson, what are the dates for these orders, okay, all those things you can see. But anyway, so why this thing is called star schema? It's because the if you look at the diagram, it looks like a star. That's it, nothing else. Okay, so that is why they call it a star schema. Okay, uh, so basically the only based by the look of the diagram, you can say okay, they named it okay star schema. Okay, when I after I show you the Snowflake schema, you will understand the difference between these two schemas. Okay. Mhm. 200. Okay, the snowflake schema. Snowflaking is a method of normalizing the dimension tables in a star schema. When you completely normalize all the dimension tables for the restaurant structure resembles a snowflake with the fact table in the middle. Okay, 11:7. Let's see the figure. It will be easy. You will understand. Simple star schema. Okay, we have this. This is a snowflake schema. So I'll tell you the difference. Okay, this table. What is this table?
It's a fact.
Fact table.
Fact table, and this is a dimension. This is a dimension. These are all dimensions. Okay.
Mm. Yes.
Yes, sir.
So in the star schema, you only have basically multiple dimension tables connected to one fact table, right?
Yeah.
Yes.
This the other diagram, right? So multiple fact table is okay. Another thing, it's not only four tables. It could be any other tables that can connect to a fact table. You can call that a star schema. You guys understand?
Yeah.
Yes.
Not only because it is showing four tables here, it doesn't mean that only four tables be connected to one fact table, then it will be a star schema. It's not. You can collect multiple tables, um, and then you can call it a star schema. You can collect any number of tables to one fact table. But here, if you see the difference, what is the difference is here these two tables they are not directly connected to fact table, right?
Yeah.
Yeah, these are also dimension tables. Category is a dimension table, brand is a dimension table, but it is not directly connected to fact table. They are connected each other, right?
Yeah.
So if this link is connected to here, and if this link is connected here, this could be a what schema?
Star schema.
Star schema. Yeah. Since it is not connected directly to the fact table, they are connected each other. Then again, the product table is connected to fact table. That is why it's called. So then it is called a
Okay.
what do you call
Snowflake schema.
yeah, exactly, Snowflake schema. So there is a difference between those two. And another two things I wanted to tell you is, okay, so now we know the basic thing, what is the star schema and what is Snowflake schema. Okay, for this, I want you guys to read for tomorrow uh, only these two things, okay? Normalization and denormalization. Okay, so we have 10 more minutes. Normalization and denormalization. Okay, I think let's go with normalization and denormalization today. Slowly changing dimension, I'll explain tomorrow for some time, for a few minutes. Then we can start SQL. From tomorrow, we are starting Oracle. Okay. Do you guys, by any chance, do you guys have the Oracle or any other database installed on your PC?
SQL.
I have
I have
SQL
SQL.
Server.
SQL Server is installed.
Yes.
Yes.
Okay. Okay. SQL Server is fine too.
You're showing Oracle SQL Server. What is the difference? Oracle SQL Server and
Oracle is a different database. SQL Server is a different database owned by different companies. Oracle is owned by Oracle. SQL Server is owned by Microsoft. That's it. They have their own database.
But you're showing
IBM has its
Oracle
own database.
Server.
I'm sorry.
Showing Oracle SQL Server, right? In your system, it's showing like Oracle SQL Server.
Oh, I mean, we have multiple databases. We have a DB2. This is Oracle. We also use SQL Server. We have multiple databases. Yes.
Oh, its name is Oracle SQL, right?
Where? No. Oracle is different. SQL Server is different.
Okay.
Microsoft SQL Server. Oracle is a different database.
Okay.
Okay. So anyway, so it doesn't matter what database do you use, but we just want to know the basics of SQL. Okay. So you can actually install Oracle also in your PC. If you go to Oracle website, you can install Oracle database in your PC, and then you can practice also.
Yes.
If you want. Okay. Okay. So let's cover the normalization and denormalization. Okay, why I wanted to tell you normalization, denormalization is because if you see this, where was it? Snowflake schema. This is a Snowflake schema also, right? Because it is connected, different. They connected each other, then it connected. So this is basically the Snowflake schema is more normalized. Okay, normalized. But star schema is denormalized. Okay, that is why. So those are the two things for star schema and the Snowflake schema. I will explain what is normalization and denormalization. Okay, here you can see snowflaking or normalization of the dimension tables can be achieved in a few different ways. When you want to snowflake, examine the contents and normal usage of each dimension table. I can find anything. I have my own documentation. Actually, I created so many PDFs and all those things, but this is my office laptop. I don't have anything in this laptop. I can connect a USB to this laptop. So that is the problem. Okay. So first thing we'll go to data normalization, database normalization. Okay. Database normalization is the process of organizing data into tables in such a way that the results of using the database are always unambiguous and as intended. Such normalization is in strict to relational database theory. It may have the effect of duplicating data within the database and often results in creation of additional tables. Okay, simple concept. Data normalization is nothing but, if you see the snowflake schema diagram, you might have already understood what is the
Normalization.
normalization means. 293. Okay, so normalization. Okay, if you see product, right? What table is this one? Product.
Dimension. Dimension table.
Right, dimension, product dimension table. Okay, so you have all the product information here, but you also have a product information is broken into a uh, or drilled into a different table called category, right?
Yeah.
Product category. But if you see here, brand is also broken into a different table, right?
Yeah. Yeah.
Oh, come on. Okay, if you see the star schema, what happened here? You have the product category in the same table. You have brand name in the same table. You have package details in the same table in the Snowflake schema. Okay, but in the sorry, in star schema, but in the Snowflake schema, this table is further divided into multiple tables and then connected using their own key. So what is happening here is basically normalizing. So you are taking one table and then normalizing into a few more tables. That means you are just creating additional tables, then you are creating additional keys to connect those tables. Okay, so basically your data warehouse is more normalized. Okay, so then what happens if your data warehouse is more normalized? Uh, your data is, there is a good chance
Repetition.
of your data is duplicated. Okay, your data is duplicated because
Yeah.
you have the same name here and here and here, right? So yeah, that is a normalization. Basically normalization is nothing but uh, creating subset of tables for the same tables. Okay,
Yes, sir.
so denormalization is what? So now it's very simple. Denormalization is uh, putting normalized table together is a denormalization. So you have in the star schema, you have more denormalized data. Okay, so that's it. That is the difference. There is nothing else. Okay, so if the data is normalized, there is a good chance you have more duplicates. But if it is data is not normalized, you don't have that problem. So it is based on the organization that they can have a star. They can use star schema concept. They can use a snowflake schema concept. Because star schema have only very few tables. The maintenance is very simple, but in case of snowflake schema, you have so many tables, you have duplicates, and then your data is more normalized, but the maintenance is also more because you have more tables, you need more space. You
Yeah.
have more space means you need more hardware. right?
Yes.
That means you need more disks. So that is the thing. So you need, if the company is using Snowflake schema, then you need more maintenance. If the company is using star schema, there is not very less maintenance. So they have their own advantages and disadvantages. Okay, but for the data wise, the Snowflake schema is good because the queries run faster because they have their own keys. Okay, but in case of star schema, the queries run slower because we have so much of data is in one table.
Yes.
Okay.
Yeah.
Okay, so that is the thing. But I want to you guys to read the normalization and denormalization for tomorrow. I'm going to ask you questions for tomorrow. Okay,
Yes.
you guys have to go through normalization and denormalization. Okay, these are not simple concepts, but even if I explain, you guys have to read your own. Then only it will be easy for you guys. Okay, so okay, I have to go to a different meeting. So please, guys, read these concepts before coming to the class tomorrow. If you can, go through the slowly changing dimensions also. I'm going to explain tomorrow. It is also it's a very easy concept, but it is very important to ETL. Okay.
Yes.
Okay.
Okay. So I will send you this document in the email. Okay. I think I have you guys your emails. I will send you in the email so that you will have idea like what we discussed. Okay. Every
Okay.
day I will add this and send it to you.
Yes.
Okay. Good.
Uh, okay. Okay, guys. See you tomorrow. Right.
Thank you.
Yeah. Bye.